Okay, should we get started?
Yes, please.
Welcome everyone. Good day. This is a session of the DETNET working group at IETF 122. I'm János Farkas, co-chair the working group with Lou Berger, who is on site. I'm remote this time. And we also have our secretary, Yves Schuler, remote. So on this slide is the IETF Note 12, the summary of the rules and policies we conduct our work in IETF. If you are not familiar with these rules, please check them at your own leisure. I would like to remind you that by participating in IETF, you agree to follow these rules and policies. And also remind you that everything you say is a contribution and it becomes our permanent record like any other kind of contribution. Next slide is about how do we conduct our work, and would like to highlight here the professional behavior. So stay professional, please, in reflections and so on. For this one, on-site, please join the on-site tool and record attendance for the electronic blue sheet. And also for the queuing, please use the tool for queuing up. That's the way we can have a single queue, and that's what we will follow. I would like to highlight from this slide the note-taking. Lou also gave the link to the chat window. It is a joint note-taking for the group. So please do join the note-taking, check what has been said, and make corrections on the fly if needed. This is our agenda. There was some last-minute change. Some of the requests we not noticed, so they were added last minute. We still fit in our 2 hours. This is why the change. So we are going to detail a bit more. We have one of the working group documents and further individual contributions on the agenda. And as a reminder, the working group document authors, please focus on what are the changes made from previous version, what are the plans to progress the document, and so on. And for the contributions, please focus on what the contribution addresses out of the charter of the working group, why is it relevant for the working group, and so on. We have this is a status update of working group documents. I'm currently working on. We have the raw technologies, which is scheduled for the April telechat, so it's getting done really. And we had the 2 documents which had the working group last call, the raw architecture and the DETNET control airplane framework. They go somewhat hand in hand. And the last edits of the controller framework were actually to make sure that the wireless work, the raw work, fits in. As for the raw architecture, we consider it ready. It is with the Shepherd. And for the controller plane, it's almost, but a revision is needed. So we are expecting one more revision and then Shepherd write-up, and then we expect to move on with them. There is no document that had been recently adopted or anything like that, and we published RFCs beforehand, no new RFCs at this point. We have working group documents that are not on the agenda. The scaling requirement is not on the agenda because it's a bit of a kind of part, waiting for the solutions work to be developed. And we have multiple working group documents that have been expired, no progress actually. Liaisons. We have sent a liaison to ITOT Study Group 13. We discussed it at the last IETF and onwards in the list. This is about deterministic networking work items in Study Group 13. You can find the details. I mean, the link is here and it's posted. And we have one new liaison that we received. It is from ITUT, the IMT 2020 new work items. This is actually multiple IETF working groups receive the very same liaison, C committees, and so on. And we typically respond together. That's the plan this time as well. But if anybody sees the need for any specific, DETNET specific response, then please bring it up on the list. And next, this slide is about a reminder about our IPR process. You are well aware. We do IPR calls at certain stages when we progress with our documents and we follow this procedure. It's important to be clear on these aspects. Uh, Also, a reminder on the document status. We expect every working group document authors to either provide a slot request before an IETF meeting or provide a written status update to the list. This is an input to a session like this one to be able to discuss hot topics. We have introduced this a while back. We progress mainly our work on the list, so please do use the list. But we have other tools and possibilities. We can set up virtual meetings as needed, or if there's a need, if authors see the need, please contact us, the chairs. We can set up virtual meetings or interims if you see the need to progress the work. And the last slide is about a potential workshop at the next IETF meeting between us, the DETNET Working Group, and the IEEE 2.1 TSN Task Group. Next meeting, July, Madrid, the two organizations will be back to back. First, IETF meets, and then the IEEE 2.2 plenary is in the very same hotel. This is the first time ever since 2018 we had such an occasion in Bangkok, and we had actually a joint full-day workshop at the time in Bangkok, which I think was very good and were appreciated by many people afterwards. So the idea is to leverage again the fact that we are back to back in the same hotel. Uh, this time it would be what we have in mind, Lou and myself so far, is a half-day workshop in the afternoon because it is a Saturday in between the two meetings. It's July 26th, and there is a coordination team between the two organizations, which also plan an in-person workshop, and we would follow that workshop in the same day in the remaining time in the afternoon. This is a draft agenda. We crafted together a very early draft agenda, and we will take it, so to say, from the Bangkok workshop. The Bangkok workshop was at the beginning of our work. Both of the groups have progressed a lot, produced standards, and this would be about how do we continue the work, what needs to be done, and so on. That's the basic idea. We are about to start a doodle poll in participation because we need to get a sense of who want or will be attending. So we will be sending out an email to both lists of the both groups, and please fill in the doodle poll if you will be there in person. Honestly, I don't know about the remote participation possibilities yet, but the primary goal really is in-person workshop for exchanging ideas and so on. And any comments? This was the last slide. Maybe we have a few minutes for questions, reflections.
I would really like to hear, or we'd really like to hear from authors of the couple of drafts that are on the slides, whether they're interested in presenting, whether they'll be present. We have both the requirements document listed there, as well as framework. or I guess that's really taxonomy. I'm not sure what framework was there, but
Yeah, I think I will be there in person and make some presentation, a couple of drafts.
and that was Janu. Thank you.
Thank you.
Yes.
Yeah, as far as what's missing, so
And that's Torless.
yep, that's Torless, exactly. No, I was thinking we do have the metadata there, right? So it should show, yeah. Yeah, so I remember 2018, so that was great. So hopefully we're going to repeat that. I also remember that we had, industry people brought in from TSN, and I was asking twice from two different organization people presenting there the question. So you're working with TSN. So what are you expecting from DETNET? And the answer was, yeah, well, we've been told that all our stuff should also work with IP. So I found that somewhat underwhelming, right? So I'm wondering how we can drag out a little bit more the people who've been working with TSN to, contribute, present what do they need, what have we not done, have they understood our documents, right? So how we can do that, right? It's more a question, but I would like the answer to be better than, yeah, our stuff should work with IP. That's why somebody should do DETNET, and we don't know anything about it. So that's been my prime concern. Thanks.
Okay, so Torless, I just want to paraphrase, make sure I understood what you're saying. You're suggesting that we solicit the TSN community to see if they have any specific questions on DETNET, questions to the working group, questions on our work.
Yeah, so I mean, and I'm not sure about exactly the timeline, but it doesn't even necessarily have to be in this, presentation, but after presentation workshop style. We could hopefully also have another slot for an hour or so to, all the DETNET questions you were, always afraid to ask, right? So something like that, more interactive with the people from the industry that only have TSN experience, right? So kind of what can we best do to sell to that community?
Yeah, I think that's an interesting addition. We could also poll or solicit our community to see what questions we have for the TSN
Yeah,
group.
of course.
So I think that's a really good suggestion. Thank you.
If anybody wants to represent TSN interests, of course, I'm more interested to sell DETNET.
Right, thank you. I do want to point out that we have DETNET and TSN in the real world call for presentations. So if you wanted to, I don't want to use the word sell or promote, but if you wanted to talk about your own experiences in the real world and highlight that from the DETNET perspective to the TSN community, that's an opportunity. And that's not just the tour list, that's to everyone here physically, virtually, or even listening to the recording.
Can I? Yeah. Carlos Bernardo, so on this point, I just wanted to ask or maybe propose that people like me, for example, being local in Madrid, I think something that we can also do is try to get in contact with industry present in Madrid, Spain, that may be interested or maybe already doing things in the TSN DETNET area to be there, that probably are not IETF regular attendees, so they are not very much aware of what we do, and that may be a good opportunity for them to be there, present what they do, and see whether there are potential things of interest from TSN DETNET community. So that's something that I can try to do and try to invite people to be there.
Yeah,
That would be really good, I think. Yeah.
And we do want to follow up the discussion here with email to the chairs if you want to present on a particular topic, or if you're one of the authors, if your willingness to present will follow. I heard Janu, but I didn't hear from other authors. But please send it to the chairs so we can track that.
Well, I would certainly propose that, all the folks interested in the evolution of that queuing stuff, right, from the large scale stuff or so, get together and can kind of work out on that 30-minute slot in terms of the analysis we've done of the existing mechanisms, because quite frankly, outside of INSURF RFC at 2211, all the things we would expect come from TSN, and what we're thinking to go beyond that, right? So, and hopefully can do that collaboratively. And the other point, so I'd certainly, be happy to kind of, help that and work with the others on that. The other part that I've also, in terms of jealousy, to go back to that, to TSN, in terms of, right, much more people know about TSN in industry. I think the same is true in research, right? So we have one or two really great research contributors, but I think there are a lot more in TSN. And so maybe they could also become more interested in DETNET. And so that's a little bit the question of how to best reach out to them. Maybe we can figure that out by when there is some plan for that, that we also, are trying to see that, there are things that are addressing research, right? So the queuing being one example, of course, right? There are other aspects as well. And then when we have the plan for the stuff, that we can also distribute that to the typical research community mails. And of course, the latest changes that we have, which are that you need to have data tracker account and be remotely registered for the IETF. If we really want to make this, broader event, it would be great if we get an exception for that workshop, so that people without even remote registration can participate in the workshop remotely. I'm especially thinking of researchers.
Okay, thank you for that. Thankfully, we have our ADs in the room. And I say ADs because we have John, who we've appreciated him being our ID for a number of years, and he's handing off to Ketan, who's also here. I don't think you take over until Wednesday, right? But so we appreciate you both being here, and we really appreciate working with John in the past and Ketan in the future. So they're the ones who are going to have to help us with that. Actually, John is lucky; he just hands it off to Ketan.
Many thanks for your efforts as AD, John, and thank you, Ketan, for taking over. One last word on the participation on this one. Of course, there will be possibility to follow up discussions, the open mic at the end, and actually for IEEE 802, they only have a weekly pass typically, but for this occasion, they just approved to have a one-day pass. So when you are doing your booking, you might consider arranging your trip in a way that if you want to experience IEEE 802 or have discussions on the topics there following week, you can get a one-day pass.
So we actually are over time on this, so we're going to move on. Jinu?
Hello, I'm Jinu Zhang. I'm going to present about the taxonomy draft, data plane enhancement taxonomy. Next page, please. Yeah, here is the resolution we have made in the previous meeting. The resolution was like this. At most one solution per a category will be selected and progressed as a working group document. So we have to come up with only a few categories within which solutions can be suitable to DETNET. But we have to consider that taxonomy draft was suggesting 6 functional criteria. So if 2 categories are distinguished by a single criteria, then there can be around 64 groups or categories. So that is too many. So we need some exclusion and merging of criteria and categories based on their interdependencies and properties. Next page, please. So before going any further, let's define some terminologies very clearly. So solution is a set of data plane functional entities, such as queue, scheduler, and regulators. A taxonomy is a system or systematic method by which a solution is put into a category. Okay? The category is a set of solutions that is put together by one or more criteria. So we are coming with some criteria, which is very important. So criterion, which is singular, is a principle or standard by which a solution can be judged or decided to be put into a certain category. So we use the term taxonomy, category, criteria, which are illustrated on the right side of the presentation. So you can take a look. Further, there is a so-called level of category, which can be defined as the number of criteria that are used to determine a category. And finally, we have so-called suitable category. Suitable category is what we are seeking for, actually. This is a category within which solutions can be suitable for deterministic networking. These are illustrated on the right side. So this is an example illustration. So the whole system is a taxonomy. And there is a one criterion called periodicity. Periodicity can categorize into two different categories, non-periodic category and periodic category. And by definition, this is a level 1 category because only the single criterion is used for the categorization of these two categories, okay? And if we use another criterion, so-called traffic granularity, this can be further divided into these four different categories. These are level 2 category because two different criterion or two different criteria have been used for the categorization. So this is level 2 category. And this is another example. There is a famous solution called TAS and CQF. This can be put into this category. This is just an example. Okay, so this is the result. This is the result of the finding suitable categories. The whole document has been restructured. The section 5, which has, section 5 was about the functional characteristics taxonomy. There were 6 functional criteria, but now it has only 4. Periodicity, traffic granularity, time bounds, service order. So it is kind of simplified. The newly put section 6, whose title is Suitable Categories for DETNET, now has 7 suitable categories. So we have, as a result, 7 suitable categories. As you can see, section 6.1, right bounded category is a level 1 category. And 6.2 and 6.3, these are level 2 categories, flow level and periodic bounded. Sorry, this is level 3 category. So flow level, periodic, and bounded category, and so on. From now on, I will show you how these 7 suitable categories have been obtained. So the basic approach we took to come up with only a few suitable categories are binding of criteria and prioritization of criteria and the exclusion of some categories. So binding of criteria, means we put multiple criteria into single criterion. And only the performance-related criterion or performance-related criteria, this one is excluded. And functional criteria was merged into 4, which was 6, but now has only 4 functional criteria. These 4 functional criteria was used to come up with suitable categories. And among these 4 functional criteria, we prioritize those 4 criteria, which is more significant or not. And finally, based on some internal discussion, we excluded some of categories that are not suitable to DETNET. So this is a basic principle. And from now on, I'll go a little bit into detail. But I will try to explain it as quick as possible. So the important criterion here is the time bounds. Time bounds is a newly defined criterion, which are made by merging work conserving and target transmission time criteria. So these 2 criteria have been merged into single time bounds criterion. And this criterion is very important. It is considered the most significant criterion of 4. By this criterion, these 4 categories have been made. The first one is unbounded, left-bounded, right-bounded, and bounded. Unbounded solution does not have any bound, which is for sure. Left-bounded solution has minimum time bound, but not the maximum time bound. Okay, what is the minimum time bound? This is very important definition to understand these categories. Okay, you have to concentrate. This minimum time bound is the earliest packet service completion time allowed. The term allowed is very important. So there is a very specific time limit that is allowed, before which the service completion should not be done. So a good example of such a solution is a regulator or shaper. If you regulate some flow, you do not allow packet go into the link as soon as possible. You hold the packet for some time, and when the time is allowed, then you let the packet go, okay? So such a regulator or shaper is a good example of left-bounded solution, okay? So the next one is a right-bounded solution. The right-bounded solution, on the other hand, has only the maximum time bound, not the minimum time bound. What is the maximum time bound? It is very similarly defined. A maximum time bound is the latest packet service completion time allowed. So when a solution has maximum time bound, there is a specific time that a packet cannot be transmitted after that time bound, okay? So finally, the bounded category has both minimum time bound and maximum time bound. So the term left and right can be a little bit awkward to you, but this is term from the mathematics. Time interval can be defined right bounded or left bounded. It has a finite left bound value, then it is left bounded, and so on. So these are the terms I accepted from the mathematics. So maybe you have some question here, but I can take question later. So what I have said is described in this illustration. The time bounds criterion categorized into 4 different categories like this. And we defined that this time bounds criterion is the most significant. So this comes up in the very up level. So the second consideration is from that time bound criterion as well. If you think carefully, for a solution with only max time bound, the maximum bounds of maximum time bounds of packets directly decide the scheduling order. So for the right bounded solution, no other criteria is important because that maximum time bound decides the service order of the packet. Okay. So here, for the right-bounded solution, no more categorization is necessary, and this makes the right-bounded category to be a suitable category, provided that maximum time bound can be met. Otherwise, it has no meaning. Okay. So all of a sudden, we come up with a first suitable category called right-bounded category. This yellow box represents the suitable category. So if a solution assures every packet is right-bounded at every node, it is by its nature, it is suitable for DETNET. Okay, yeah, you can imagine such a solution. Okay, let's move forward. And we also merge two different criteria into one, that is periodicity and network synchronization, which were two different categorization methods, but we merged them into single called periodicity. Because every periodic solution, every periodic DETNET solution should be frequency synchronous. In previous categorization methodology, based on the network synchronization of solution can be phase synchronous, frequency synchronous, or asynchronous, or synchronous, okay? But it turns out that every DETNET solution has to be frequency synchronous. So the network synchronization categorization is kind of meaningless. So these two are merged into just periodicity. And okay, another thing we have to consider was that the interdependencies of criteria. Solutions without maximum time bound cannot be described by periodicity. They should be described by the service order, which is another criterion. Bounded solutions are better described by the periodicity. The service order within a slot. Actually, the bounded solution naturally have a slot for a packet. So every packet is assigned a slot. And the packet has to be transmitted within the slot. Okay? Exactly when in that slot is not important for bounded solutions. So we decide that unbounded and left-bounded solution will be further categorized by the service order, where the bounded solution will be further categorized by the periodicity. So, and there are some more consideration, but you can take a look. I will go directly into the kind of result here. So this is the illustration of what I have explained so far. So the first categorization was based on the time bound, and the second level categorization is either based on the service order or periodicity. And for unbounded and left-bounded solutions, the service order, this presentation material, you cannot see clearly the difference of the colors of these two boxes. But if you look carefully, these two boxes have different colors, and this shaded box represent the unsuitable categories. So what I'm trying to say is only the rate-based solution of unbounded and rate-based solution of left-bounded solutions are suitable. These two, priority-based and arrival-based solutions are cannot be tight end-to-end latency bound. And for the bounded solution, based on the periodicity, there is a non-periodic bounded solution and periodic bounded solution. They both are suitable. And there is another final criterion called traffic granularity, which was categorized the solutions into flow aggregate, and class. But somehow we decide that flow aggregate and flow are the same thing, because there are some cases where the distinction between flow aggregate and flow are blurred. This is also another technical topic, but I will tell you in the future if necessary. So currently under traffic granularity, we have flow level and class level. And yeah, based on this categorization, we are almost to the conclusion. These yellow boxed solutions are suitable. There are already 7, 1, 2, 3, 4, 5, 6, 7. And as you can see, flow level rate-based unbounded, flow level rate-based left-bounded, right bounded, and flow level, all the bounded solutions are suitable. Then you may ask at this point, why these bounded solutions are put into 4 different categories? They cannot be in the single category? Yes, the answer is yes. But still, we have divided this bounded category into 4 different suitable categories because each different level 3 categories are quite different in their characteristic. And there are lots of currently suggested solutions matched into different category. So we decide to separate them into 4. I know that this is not a very good answer, but this is the current answer. So let's go to the conclusion. This is the conclusion. So this is the result. There are 7 categories that we have defined as suitable. And hopefully, we can select 1 solution in each category and make progress. Thank you. So this is a future plan. The document is quite lengthy now. I think some of them must be, some of the contents of the document must be extracted and be clarified so that the document should be more stabilized. And after that, we'll start approval process. But you have to be very careful that this document is not meant to nominate or select candidates for each suitable categories. Thank you.
Do you mind going back 2 slides?
Maybe here.
1 more. So I'd like to bring this the slide and the document to the attention of any author of a queuing solution. Now is the time to go look and see how your solution maps into the document, which will basically be one of the categories on the slide. If you find that your document doesn't map well or your solution doesn't map well, we should hear about it on the list. We really want to hear if you think these categories are the right categories, not so much about something that doesn't apply to your queuing solution, but the ones that do apply. So if you find that your queuing solution matches a category, please update your document to reference this document, the taxonomy, and say this is where you fit in. If you find you don't fit in, then let's hear about it on the list. So want to make sure that authors of queuing solutions are paying attention to this document because it gives us a context for evaluation and selection. To help move things along, we are thinking about an interim to review the different queuing solutions and where they fit and see if we can reach agreement on that within the working group. So we would be asking each set of authors to present where they see they fit and for us to discuss and agree on that as a group, and then end up with a consolidated, think of it as a table of solutions and mapping to categories. And that will help us identify where we have overlapping ones and where we have separate solutions, because we'd like to move forward with adopting solutions. And we had for a few meetings now, we've been talking about that this is the framework for that. And we the chairs think we're at a good place to now move forward. We've been a little, I don't want to say stuck, because we've been making progress with this document, and thank you to Janu and its co-authors for that very important work. But now's the time we really want to start whittling down on the solutions. So we are slightly over time, but we have a minute or two if any of the any of the queuing authors want to make a comment or ask a question.
Yeah, hello. One question is that we have 7 suitable categories. Does it mean that we will suggest a working group to adopt 7 solutions draft or only 1 framework solution draft?
We hope we won't have 7 queuing solutions. That's a lot. But we suspect that there's some overlap. Will we adopt multiple? It gives us a framework to allow us to adopt multiple if it makes sense. I think that answers the question, but if I didn't get it.
Okay, thank you.
All right, we're going to move. Thank you very much, Janu.
You're
Authors,
welcome.
you're actually up next.
Yeah. This one will be short, maybe less than 3 minutes. So this is about the latency guarantee with stateless fair queuing, so-called C-score. I'm Jinu Zhang again. This is the brief history of C-score. It was included in another document, so-called Asynchronous Data Plane Framework, which was started in 2022 June. And after a year, the working group suggested to put this solution into another separated document. So this draft has been created in the 2023 June. So currently it is revision 4. And this has been quite through the intensive debates, quite intensive, I would say, and discussions and revisions up until IETF 119. But after that, almost no comments afterward. So as a result, the C-score can be put into the first suitable category, which is flow level, rate-based, unbounded. C-score does not have specified any minimum or maximum time bound, so it's kind of free. As far as I know, C-score is the only solution currently being suggested in the first suitable category. And it has a number of advantages. It has a very easy admission control procedure, which depends only on the service rate, the sum of the service rates of the flows. That's the only criteria for the admission, which is very simple. And it has an excellent flow isolation, thus protection capability. Once a flow is admitted, that flow is not affected by any other flow's fluctuation. What is fluctuation? We define it as flow joins, flow leaves, or even misbehaviors, malbehaviors. So it is very strong in terms of the flow protection. And it also has the flexibility to adjust its latency bound by adjusting the service rate. And last but not the least, it has an excellent statistical performance because it is work conserving. Thank you. So the future plan is that, yeah. Thank you.
Okay, thank you very much.
Thank you very much.
Appreciate the good work on the prior draft and the update on this draft. Peng, I believe you're up. Maybe 1 second on that clicker.
Pony from China Mobile, and it's a EDF deadline-based forwarding, and I believe this draft has been presented several times, and the main updates as the evaluation on the ring mesh reference topology according to the taxonomy draft, and we have some supplements the existing research conclusions. And there are also other minor modifications of the text. So it's a briefly overview of the EDF solutions. It is based on the deadline time and different flows are assigned in different delays levels to ensure the scheduling before their deadline. So the time parameters has 3: one's arrival time and planned residence time and latency division. So we should insert the packet into the sorted queue. So for the queuing model, one is the PIFO and another could be RPQ. And there has some conditions for it. It's about during a certain period of time, how much packet it can be dealt with. Um, and when the actual arrivals violates the eligible arrival, it should take reshaping or latency compensation. So this is the main updates of the new version. It's the evaluation on the ring mesh topology. And yes, there was some process of the calculations, and more or less it is a little complexity. So we just gave the result of the evaluation. We assume the worst cases is that the size are one flow set generated by itself, and it receives 6 flow sets from the upper stream nodes, and it means that every node will generate some traffic flows. So the design delay level resource table listed here, the delay level will be 225, and the burst results, bandwidth results, are also calculated here. And we could deal with the control flow, audio flow, and the video flow of 7 flow sets. So in the same process, in the core network, we also assumed worst cases, there are 12 burst flows, and 10 of the 12, the size are 1, and 2 of the 12 flows, the size are 30. So we calculate the delay level of the different flows. For example, for the control and the audio flows, the delay level could be 400. And for the video of the flow sets, the delay level could be 700. So we could calculate the end-to-end band latency for the control and audio flows is 4.75, and also for the video is 5.95. So it's just to evaluation the solution itself according to the taxonomy draft here. So okay. Also the jitter is 0 because we assume on-time model for it. And for the EDF, the on-time or in-time model will matched in different categories according to the taxonomy draft. For the in-time model, it will be the final bound, and for the on-time model, it will be the interval bound non-parity class level. So here's the summary of the comments we received since the last several meetings. We just deal with some comments with from Xuesong to clarify what is the main contribution of the EDF draft, and also from who? Let me see. Yes, Cheng Duoping. What preparations should be made before the deadline, such as bandwidth and path planning. Yes, and also others discussion in the entry and other comments. So next step is that to think well with the plan of the working group, data plan, solutions, adoptions, and there any questions or comments?
I think we'll move on to the next slide. It'll take us just a moment to switch over.
Okay, thank you. Okay, so it's a TQF, time slot queuing and forwarding. It's another draft, and it's also in the version 10. Yes. So the main updates is also the evaluation of the ring mesh topology according to the taxonomy draft. So first, a briefly overview of the TQF. It has main contribution of the orchestration period, and we need to set up the base time slot mapping and the forwarding time slot mapping in the solutions to have a mapping between the adjacent nodes and also to decide where to insert the flow of the packet. So it looks like a little like the CQF and the TS. So we can also yes, the CQF is also one typical conditions of the TS. So the difference is that so first it has the orchestration period, and to let the package insert into the period with its own latency requirement, and in the period it also has a scheduling period. Yes, so there is a OP and also a SP. And for the SP, they will have two different implementation methods. One is sorted queue, and another is the round-robin queues, which will have different demands on the hardware. So comparing it to the CQF, the SP is similar to the round-robin bins, and it allows different slot lengths between nodes, while the CQF is a cycle mapping based on the same cycle length. So in the OP, it will have the different lengths of the queue. And comparing it with the TS, and the OP is similar to the gating cycle, but there's no gating control list to be calculated in the control plan and then be sent to the data plan. So if there's M queues, and if the M we set it to be 1, it looks like the TS, because in the TS, they will have one queue to deal with the deterministic or TSN traffic flows. And we can also look it like it to split the one deterministic queues into several queues, and it will be the TQF. So the main updates of the evaluation on the ring mesh topology is that we select a 5 millisecond with a time slot length of 100, and the reason we select it is because it is minimum common multiple. Yes, so we give a schedule of the time slots and the corresponding flows. We have 15 time slots, and the burst results is 100 kbps per slot. So we can arrange the control flow, audio flow, and video flow into the 50 time slot. And in the core network, we can with the same ways, we can also arrange the traffic flows into the 50 time slots. So we can calculate the end-to-end bounded latency for the control flow and for the audio flow and also for the video flows. They are also within acceptable latency. We also didn't really give the details of the calculation, because in the ring mesh topology proposed by the taxonomy draft, sometimes it will has complex situations. Every node generated some traffics and also receives some traffics from the upstream. nodes. And it will have bounded jitter is about the cycle interval. Yes. So here's also a summary of the received comments. About the Pivo's implementation and split the draft to data plan and control plans one. So this is for the data plans draft. And we had also presented this into 6-man work group, but we had received no comments. And there's also some discussions in the interim and the mailing list. So we think we all have a response to the comments. So the next step, it all seems like the previous draft. We will think well with the working groups plan and any questions or comments.
Comments, questions? Okay, thank you so much.
Thank you.
We're going to go out of order here because the next speaker has a conflict. So we're going to move on to, I believe it's Xinfeng. Oh, you're here. All right, so sorry about that. So we're going to go in order.
I cannot make it, but
You'll have the clicker, but just give us 1 second to get the slides
thank
up.
you.
Takes a moment to switch slides.
Okay. Now it's thank you, Mr. Chair, and good morning to everyone here. This is the second revision of the draft. The draft has been presented half a year back in Vancouver, IETF Vancouver, about flow aggregation for enhanced the DETNET. And this is today doing presentation on behalf of the co-authors. Oh, yes. Okay. This is the update. Here is the slide with the words difference. So the first bullet is regarding some comments we collected from the meeting 120 in Vancouver. Thank you for Torres, Janus, and Lo about all kind of comments. And those comments are detailed in the next bullet. Based and also to reflect the change in the new revision number 2. The first one to is split the original section 2. In the next slide, I'm going to show the picture about the comparison. The next, the section 2 originally is like a recapture of the objective, requirement, and the principal part. And then we split that section number 2, and then to get one standalone section 4 to highlight the proposed enhancement when compared to current DETNET spec. And also we add a new subsection 4.3 for flow coordination. Here is to address one comments from IETF 120. Torres mentioned actually, thank you, about the flow in the living part. Here we all call it like a flow coordination. The terminology is well, terminology different, but the meaning the same. And then some editorial revisions. Okay, here is the graphic comparison between the version number 0 and the number 2. Here, you look at originally the section 2, and then has been split, it's called section 3, and also we put a section number 4 for the enhanced consideration for flow aggregation, and there is really some very the contribution or merits of the draft about, okay, in order to do flow aggregation, what are some enhanced considerations for flow, like flow classification, identification, and coordination. And then with those like objective requirements, principles, and also the considered enhancement for flow aggregation, we use the 5GS as a realization example to consider, okay, then the general framework, what we have proposed in the draft, how it's going to be applied to realize the flow aggregation in 5GS DETNET. So this is based on, those changes are based on the comments from the two IETF 120. Okay, here this is a recapture about okay what we have proposed. This one is no significant changes from the revision number 1 about objective requirement and principles, and then the 3 bullets. One is to aggregate DETNET flows across domains, and then the second is to aggregate it or fine-grain the flow level QoS provisionings. And then the number 3 is like the scale down the state maintenance at the transit node. So we all know, okay, for flow aggregation, we can do something better. You know, RFC 8655 and also the scaling document in the working group draft, they do talk about the flow aggregation, but here in the draft, we unfold those, we believe those the document are kind of more abstract. Well, in this draft, in our draft, we unfold all those things and provide a lot of details, even some implementation consideration in the draft. So that is the merit things of the draft when compared with the general description in the other like RFC or document here. So we have a lot of details in our individual draft right now. This is a recapture, and then there's an enhancement consideration. So basically we have those objectives, we have the requirement and the principle here, and then in order to do the flow aggregation, what are the enhancement considerations? So we have a three bullets here, like a flow classification. So it's like we in the draft we mentioned, okay, like DETNET flows can be classified into predefined, and but this is on the level of the aggregation class. Okay, so it's like and then the next one will be the flow identification here. So okay, so we have the first one like classification. So basically, you have some predefined levels, aggregate levels here, and then now the second flow identification. So basically, like how are you going to identify those flows, like basically something like A class or something else, like in the draft we proposed, like encoding may use like DSCP for IPv4 or the TC for IPv6, or those type of the flow identification encoding method. And then we add in the new revision about the flow coordination. This is newly added and based on the comments from the IETF 120. Here, like we acknowledge the flow aggregation become more prevalent, and then the flow, here is like a drawing and the leaving very frequently will cause some variation of the traffic here. So in this draft, we add one subsection to discuss, okay, so in order to do flow aggregation, what is some enhancement consideration? And then we add the flow coordination part. This is like similar to the interleaving proposed by, I think, Portis. Yeah. So this, okay, now we have the objective, we have the requirement, we have principle, and then we have the consideration for enhancement of flow aggregation. And then we apply this, we have the generalized framework to the 5GS DETNET service, the realization example of flow aggregation. And the first bullet one, the first 3 bullets, 1, 2, 3, and the first one cross domain, the second one is the QoS provisioning, in terms of aggregated and fine-grained. And number 3 is about the state maintenance and the 5GS as a transit node. Those, this is like all the details are in the draft. And then number 4 here, it's just, okay, in order to do the enhancement, how are we going to apply those type of things like flow classification, identification, and also coordination? Here, well, I can give one example, like here, if you look at the first, this one is like an IP domain controller. It's going to provide like flow descriptions. Those flow descriptions well provided to 5GS. 5GS has a one network function, TCS, TSF, time-sensitive communication, time-sensitive function. And that one is going to use the flow, those descriptions, and then to send to the 5G, some other control functions to do the flow, provisioning, flow mapping. And then in this one, the IP domain things, it can give those flow descriptions either like a coarse grained or like a aggregated level or the fine level part, and then to do, you can use like A class, or you even can do like the whatever the DSCP based on some policies or TC things. So those things can be provided from the IP domain, the DETNET domain, to the 5GS DETNET domains. And then with all the description as like one things, and then our like a generalized framework can be applied to the 5GS as one realization example. Here, this is the consideration things. Okay, so now we have presented all the things, and then we claim, the current RFC part and also the working group draft itself. We acknowledge they do provide more abstract description of flow aggregation when compared to our draft here. We provide a lot of the details and then give the detailed description about objective, principles, and requirements. And also based on those things, we provide enhanced consideration, flow identification, classification, and coordination, and then use 5GS as one realization examples. So we believe this one does provide some useful information for the group. So from our side, and then we want to get more comments from the group, say it's a useful work for the group to consider. Yeah, thank you.
We have Christoph in queue. Are you really in queue? You keep trying to share slides, so I suspect you're not really in queue. Okay, so from a chair perspective, if we maybe back up to the second slide, or it's slide number 2, even though it may be the third slide, you're focusing on multi-domain first, and we don't have a definition for single domain. So we really would like a definition of aggregation within the domain. Also, we have a Yang model that has certain terminology in it. It'd be good to make sure to look at that Yang model, make sure you're aligned with it, and then talk about how you're doing aggregation in the context of our basically service definitions, which is in the Yang model. The Yang model has an imagined way of doing aggregation. This does not seem aligned to it. So please, if you could, get aligned with our prior RFCs and describe single domain, then multi-domain. We think this is good work. We'd like to see it progress, but it needs to be aligned with our current terminology and existing work, and single domain first, then multi-domain.
Okay, sure. Thank you.
All right. Thank you. Next up, we're going back, and we're still in regular order. Shufeng. And I apologize for, I'm sure, mispronouncing your name. Give us just one moment to get switch over.
Hello, good morning, everyone. I'm Chuan Sheng from ZT. My topic is enhanced use cases for scaling the deterministic network. This is the version 3, and we have updates from the first version to the third version, and we have presented at IETF 118. And thank you the comments from Yellows and Blue. The main updates from the first version to the third version, just like that, the first one we added 2 co-authors, the Mohand Airways, Jordan from InterDigital, and Luis from the Telefonica, and they also provided some new use cases. For example, the ISAC enabled smart factory from the ETSI organization, and we also get the international TSN from the Telefonica, and we changed the use case from computer-aware network to intelligent computing. And we also added a subsection requests to the IETF to each use case. This is to address the comment from the IETF 8118. And we also added action use case common themes to specify the new requirements with the enhanced use cases for that it is also to address the comment. We also made some editorial revision. First, this is the comparison from the first version to the third version. We have made a big change for the structure. For example, we add two section for the new use cases and we added requests to the IETF for each use cases to specify the new requirement for DETNET. And we also summarized the use case common themes for the new requirements for the DETNET. So the number one new use case is the ISAC label smart factory. It is for short for the integrated sensing and communication, ISAC. It enables the earth-based sensing for real-time environment perceptions. For example, as the figure shows, the sensing RX in the smart factory generating sensing data from the sensing signals, and it will send it to a senior core network, and it is definitely labeled senior system, and the system sensing surface consumer for the real-time decision making. So it the DETNET leads to ensure the low latency, banded jitter, and high reliability for real-time sensing data transmission and decision making. So this is the new use case from the interdigital. And the second one is the intelligent computing. It is changed from the computing aware network. The intelligent computing refers to the integration of architecture intelligence technicals with the computational methods to enhance the performance in efficiency and the capabilities of computing systems. From the figure, we show the collaboration across the different the regions for the HPC scientific research. It has specific requirements for the lab. For example, it lead to ensure reliable and predictable performance, such as latency, low packet loss, and high throughput. So the typical scenarios involve the new applications such as the AI-based scientific research, autonomous vehicles. So we summarize the common themes for the first one is the deterministic classification. We summarize all the new use cases for scaling network, and summarize the SLA requirements for the DETNET. It can be seen that there are differentiated deterministic requirements for all the use cases. The applications differ in their network ranges and their SLA requirements. For example, the bandwidth latency, the jitter, the bandwidth availability, and the packet loss, they have different requirements for their SLA requirements. And so the classification should consider the word characteristics such as the traffic specification and the service requirements. This is the first common theme. And the second common theme is the ultra low or zero packet loss. For example, some applications such as the intelligent computing it will require high throughput and low latency, and it may be data intensive transmission. It demands orthogonal packet loss, which is critical to ensure the real-time data processing. And there are other applications such as the AR, VR, it do not fit as a payload into a single IP packet, so it may be fragmented into multiple smaller checks. It has been discussed in last meeting. So it also demand zero packet loss for some checks that then it will indicate the importance for the one single chunk to be as the it can lead to the loss of the whole application. So it may demand zero packet loss for some part of the flows. This is word updates from this version. So we appreciate it to ask for working group feedback and some suggestions. Thank you.
We're going to do a quick poll. See how many of you think we should be working on this topic. So we'll just take a moment. I know you're looking for feedback. So this is a good way of getting it. And yes, it's just of who is in the room, both virtually and physically. So it's not we're not formalizing anything at this point. It's just feedback. Janu has a question. You can take the question while we're conducting the poll. You're in queue, right?
Thank you, John. Thank you for the nice presentation. I think this draft is very valuable because it suggests some real numbers. As I can see here, section 3.4 has some detailed usage scenario with the real number of the maximum delay, maximum jitter.
Yeah.
But I would like to know, how did you get this number exactly? As I read your draft, the overall requirements and overall scenarios are described, and all of a sudden the numbers appear.
Yeah.
Is there any specific process or regions, or anything you can show me to how you get these numbers? Thank you.
Yeah, the data of the requirements are from 3GPP or from the ETSI. We have clarifying the results in the draft for each use case.
So I see. So these numbers are from overall literature survey or something like that. These numbers do not come from the real experience from interdigital or any real deployment experience. They are from the literature survey.
Jadon will answer.
Hi, this is Mohammed. Can you hear me?
Yes.
You're right. I mean, they are from literature and also from some use cases are defined in 3GPP and ETSI, where different companies have actually provided this data. So they are different from different sources, actually. But we don't have any experimental results to show that these numbers are actually based on those experiments.
I see. But I would like to have some more explanation how you get this kind of conclusion. As you see the draft, the overall characteristics of the usage scenarios are described, and all of a sudden the numbers appear. I would like to fill the gap between these two. Thank you.
All right. Carlos, last question.
Yeah, sorry, Carlos Bernardo, just a comment on this Isaac use case. We are participating in a European project Multi-X where we plan to do some actual implementation and validation on this. So that could also help in providing some actual numbers.
Thank you, Carlos. And I think I would be really interested in what you get as results and to incorporate that actually in the tool.
Okay, thank you.
Yeah, we need to switch you over. This is the wrong presentation. Janos. Number 8, please.
Hello everyone, my name is Yan Yu from A3. Today I will introduce the on-time voting with the Python Q.
Oh, and before you start, I failed to summarize the status of the poll, so just excuse me. On the last one, we have a fair number of people in the room. There were very few participants. Of those who participated, it was split between yes and no opinion. So my takeaway from it is we don't have enough information, and please look at the draft and so you can participate and voice an opinion. Thank you. I'm so sorry about that.
There are simple two contents. One is the version 1 updates and main mode. Second is the version 2 updates and main mode. First of all, version 1 updates. The first report was proposed at 119 meeting. Version 1 draft updated data plane queuing operation part. Description of the relationship between the queuing delay and non-queuing delay based on node upper bound and node lower bound. And second is description of the relationship between the variable delay of end-to-end delay and node upper bound and lower bound. Version 1 main work is on-time service testing using the PyPQ with a single load because in 119 meeting, there were a comment that implementing PyPQ would be challenging. So we conduct the FPGA-based DETNET throughput test of 40G and 100 gigabps, and followed by single load PyPQ performance test. And we second version update the control plane operation part. Description of the added relationship between the maximum queuing delay depending on the buffer size and service rate. And second adaptation is a description of a relationship node upper bound and lower bound depending on the maximum queuing delay. And we try to testing on time testing on time PyPQ testing on the single pass. We perform the on-time service performance test of PyPQ across the 4 nodes in the actual Korean networks over the 417 in 5 kilometer section between the Daejeon to Busan in Korea. We testing when we testing 64 byte from to 1,518 bytes random size packet. We using the random size packet. Our FPGA based system is taken average 7 microsecond per node in a in-time mode. And for the on-time testing, we configure 50 gigabit best effort service flow, one best effort service flow, and two 40 gigabit per in-time DETNET flow service, and 2.5G on-time flow configured, and every on-time forwarding, on-time flow, we configure the node lower bound range to 45 microsecond to 5 millisecond. As a result, we can observe the delay can adjust 200 microsecond to 20 milliseconds. This is in-time service there, in-time service result, and this is we configure the on-time as a result. DETNET delay we can control the on-time the delay, and this is each configured the best step to flow was dropped by drop the almost best step flow. Next step is we will conduct an on-time service performance test of the pipe queue across the multi-pass, including the P2MP service in actual Korean network over 725 sections connecting to Seoul, Daejeon, and Busan. Thank you. Any question?
Okay, thank you. You're also next up.
Yeah.
They-
I have one section.
I'm sorry? Please go ahead.
According to the newly proposed the taxonomy draft, our mechanism is belong to the number 4 flow level non-periodic bounded category. So,
Okay, good addition. Thank you. Janos, are you going to switch slides? Thank you. Go ahead.
This is my second mechanism, non-conserving stateless core fair queuing equals N score. There's 5 contents, motivation and scheduler framework, latency and jitter bound, and operation procedure and capability analysis. First of all, motivation. The syscore is a scheduler suitable for the large-scale network that guarantee the maximum latency per flow-based rate without state management at core node. But Syscore is a schedulable work conserving approach. So jitter has a range. Therefore, we propose the N-score method that can reduce jitter while using same information as C-score. This is C-score scheduler framework and service period. In C-score, the entrance node manages the previous packet finish time and obtain the finish time of the current packet by comparing it with the arrival time and transmit the packets in ascending order of their finish time. So it has a service period arrival time to finish time as shown the red triangle, overlapping the red triangle. This is N-score scheduler framework and service period. We added concept eligible time, which means the ideal service start time. In N-score, the entrance node manages the finish time of previous packet and obtain the eligible time of current packet. And according to the obtained eligible time, determine the finish time and transmit the packets that are after the eligible time in ascending order of their finish time. So N-score has a service period of from the non-overlapping eligible time to finish time, as showing the non-overlapping this red triangle. So upper bound of latency of N-score is the same as C-score. One of the advantage of the N-score is that unlike C-score, it can be guaranteed low bound latency. So it has a less jitter than C-score. Operation procedure also similar to C-score. The entrance node manages flow level state and obtain the eligible time and finish time according to the managed information. And next node's eligible time and finish time is marked to the packet header and transmit the packet after the eligible time are transmit in ascending order of their finish time. The core nodes does not maintain any statement. Directly obtain the eligible time and finish time from the packet header and marks next node eligible time and finish time to packet header and transmit the packet packet that are after the eligible time in ascending order of the finish time. So this is capability based on taxonomy draft. N-score has 5 functional characteristics: non-periodic and asynchronous characteristic, and flow level, non-work conserving, on-time, and rate-based service order. according to the newly proposed taxonomy draft, and score belong to the second flow level rate-based left bounded category. Thank you.
Comments? Okay, then thank you. We're going to move on to the last slot, which is Carlos.
Sorry, I was looking for the button. Is there time to ask a question about that last presentation?
Sure. We actually have a little extra time. We're running ahead.
Yeah, sorry. It took me a couple minutes to find the raise hand button here.
It's always better just to come to the mic and then catch up.
Yeah, sorry. Rod Van Meter from Carey University. So I'm not a regular DETNET member, so I don't have a lot of context on this, but I'm not sure where your N-score queuing algorithm needs to be implemented in the network. Which nodes in the network are actually executing this?
Which no? Oh.
The source or the first router or core routers or along the whole path?
Edge router and core router, all of the using the N-score scheduler framework.
So at every router or only near the source?
Maybe as a co-author, I can answer to that question.
Sure.
In short, there is two different kind of nodes in the network. That is entrance node and core nodes. The entrance node maintains the flow state and do all the packet metadata marking. Okay, those packet metadata will be updated in core network and will be used in the core node. But in the core node, the flow state needs not to be maintained at all. All the core node has to do is just looking at the packet, extract the metadata, and schedule the packets according to the metadata, and update slightly. And that's it. That's the big advantage of this approach, ANSYS Core 2.
Okay, and so we're comfortable with the performance requirements, the computational requirements per packet?
That's exactly correct. Only all the computation complexity goes to the entrance node, which is located in the edge of the network, and there can be fewer number of flows compared to the core nodes.
Okay, thanks.
Thank you.
Okay, now we're moving on to Carlos. You have
Okay.
it should work.
Okay, I'm Carlos Bernardos, presenting this on behalf of also my co-author, Alain Murat. This is not the first time we present this work. This work originally was done in the raw working group, trying to identify potential gaps and start addressing those gaps by presenting a sample solution on how to enable multi-domain scenarios in wireless deterministic networking or networks. At that time, we identified already some scenarios that involved the need for connecting multiple domains with deterministic networking characteristics, in which we may have, for example, a couple of hosts, each one connected to different domain from a technology or administrative point of view. And we had the need to interconnect those domains and still provide those DETNET warranties. From that point, we have discussed this in this working group several times, and we got the feedback that we had to generalize that from only raw wireless domains to generic DETNET domains, and we already did some steps in that direction by including in the document also DETNET domains. So we now consider in the document raw to raw, like wireless to wireless interdomain connectivity, but also raw to DETNET connectivity. And at that time, and in the current draft, we identify some gaps and try to propose some temporary solutions. Those gaps and the solutions are mostly on the DETNET control plane. And actually, some of the gaps requirements were partially included in the DETNET controller framework document. As I mentioned, the latest version of this draft already consider not only raw, but raw DETNET multi-domain scenarios. This is one of the exemplary scenarios that we have in the document. We have two domains, one that is purely wireless at the top and one that is DETNET wire at the bottom. Each of the domains have a PCE, and we have those domains interconnected via multiple paths. That's an example. As I mentioned, domains may be wire or wireless, and we identify some gaps. First one is that maybe or may not be in the scope of the work in this working group is how to interconnect these domains. There may be multiple potential ways, especially if we consider wireless. Depending on that, there may be a different ending or different resulting paths that can be leveraged or can be exploited in the actual multi-domain connectivity. That is the second main gap area that we identify. For that, there may be inter-PCE work that is required and some ways of coordinating the multiple domains that are involved. The draft also includes a potential solution, but I will not go into the details of that. That's just for the sake of providing an example of solution. And in this slide, I wanted just to highlight that there is the need for inter-PCE coordination or inter-PCE work to enable this type of multi-domain DETNET connectivity. So questions to the working groups and propose next steps from my side and hopefully getting some support from you guys. I think we have already made this question and the answer was yes, there is interest in working on some kind of DETNET multi-domain draft. I have some discussion with the chairs and with other participants offline and on the mailing list on this point, and I personally plan to work on a more generic DETNET or multi-domain DETNET draft, so like draft Bernardo's DETNET multi-domain, so not DETNET raw. And maybe that time is not clear to me. In parallel to that, or as part of that effort, I would like to do some kind of PCE-based DETNET controller plane framework document where we do at least two things or two main things. One is to define, explore what we mean by multi-domain DETNET control, how that may look like, and then start working on some potential solution based on inter-PCE connectivity or inter-PCE protocol solutions. So that's what I have planned, and I would like to get some feedback from you guys. And of course, if any of you, I know that there is some interest already from some people to work on that. I will be very happy to work on a joint draft and eventually discuss that if time allows in Madrid. So comments, questions, thanks.
I'm Chuan Xiong from ZT. First, I agree with you. As mentioned, just mentioned by Lou, we need to first define the single domain and the multiple domain. This is the same thing we need to do. And second, I suggest to add some extensions. For example, the enhancement solution, the control plane extension for enhancement solution. I suggest to add this into this draft, because the framework, the control plane does not has any content with the enhancement. Yes, so we can add that part into this chapter too. So I have these two suggestions.
Okay, thanks for the comments. I think I agree. We need to consider those parts. Yes.
Yeah, I also would like to contribute on this work. Thank you.
Thanks.
Yeah, I think that's great. It does change the scope a little bit of the document from a framework to a solution document. But personally, I don't see any issue with that. Of course, we'll have to judge once we see the document. So I think your 1 and 2 will be very good, although you might reverse those, do 2 and then 1, just because how do you do multi-domain if you don't have single domain first? But we've talked about that on the list. Good additions, thank you. Janelle?
Thank you, Carlos, for the nice presentation.
Thanks.
I'll ask you a simple question. What is the definition of domain?
What is the definition of domain? Yeah, that's a good question, and that's what I think we should do in the following work, to be all of us on the same page. For me, I differentiate or I define domain on two things. One is on the actual technology that may be used. It's not the same thing to use a particular wireless technology or a wired technology, and there are even differences on potential multiple wired technologies. And the other one is on the administrative domain. So who is in charge of the actual control of that set of entities that compose a domain? And from those two perspectives, I think those are different domains, and those imply different things potentially on the solution to enable that.
Yeah, I agree to you. I agree that there can be two different criteria, but I think that's also a problem. The first, the technical view. So if you have different data plane solution in each domain, it is very clear to distinguish these two domains. But these domains can be administered by a single administrator, and vice versa. So that's the difficult part, and I would like to help you in defining those.
That will be great. I will very much like to work with you on this. And I agree that those two scenarios are, for me, in my understanding, multi-domain. So even if you have one single administrative domain with different data plane technologies, that for me is a kind of multi-domain problem. But it's also a problem if we have the same data plane technology with different administrative domains.
Right.
So both are multi-domain problems with potentially different gaps to address, but both multi-domain.
Okay, thank you.
Thank you.
Lou Berger in queue as contributor. I think we're going to have a lot of discussion here. As I read your document, I saw domain as scoped by a single PCE, basically a controller. And so it was a controller plane definition of domain, and it made a lot of sense to me. So so a single PCE would be one domain, another PCE would be a different domain. You might have coordination between them. I think that's in your draft. That scope I completely understand. The notion that different underlay technologies is the definition of domain, I personally really disagree with. Not as chair, this is as contributor, because I see no reason why a single PCE couldn't control multiple technologies. In fact, I could see benefits of it controlling multiple technologies. So I'm much more comfortable with the definition that you had in the document versus what you said at the mic. But this is the reason why we'll work on the document, and we'll clarify it. One level I'm really comfortable, the other one I actually completely disagree.
On that, I fully agree on that we have to discuss on this, and that's the benefit of this. And I also think I agree with you in the sense that I'm not saying that the solution shouldn't be based on a single PCE controlling or that definition for the solution part. But to me, I think exploring the multi-domain on the data plane thing is also useful, even though we go for the solution with a single PCE per administrative domain. I think still there are potential issues we need to explore when we have one single administrative domain with multiple technologies. And I'm not saying that for that we need multiple PCEs. I'm just saying that that may involve something that maybe is completely cover what we have and we are fine, or maybe not. I'm just saying that probably discussion on exploring that problem is useful.
I completely agree. Talking about multiple technologies running in a single control domain is interesting. I think also in multiple control domains are interesting. I'm just saying, to me, multi-domain isn't multiple technologies. Because even in a wired network, you could see multiple wired technologies being controlled by a single PCE and a single administrative domain. I don't think that makes it multi-domain. Just because you have Ethernet and point-to-point, like G709 links or OTN links, that's still one domain.
It's one administrative domain. I think it's more a terminology
it's probably
issue.
One control domain, too.
One control domain, yes. Yeah. And I agree that we may end up saying multiple technologies only involve one control domain, perfectly fine. But I think it's a good exercise to think if there is anything that is specific or that will be required by having multiple technology domains within one single control domain. Yeah.
If you, again, I think we agree on what we want to solve.
Yeah.
It's a terminology issue. I don't think, again, well, I've said it already, so
Yeah.
we'll go there. So look forward to the new draft and
Thanks.
good discussions.
Thanks for the feedback.
Yeah, thank you. So we have one last thing. We wanted to highlight again our appreciation of John's efforts and contribution to the IETF as a whole and to our working group. So we just want to say thank you. I think Janos wants to say something too.
Yes, thank you very much, John. And it's been a lot, I know. It's been a busy time, and there were multiple groups. Like we had a row working group. I think it started with you and merging it into DETNET and all kinds of stuff. So many thanks for all the efforts.
Thank you so much. And yeah, you've been a great group to work with and, made it easy. So appreciate it.
And we expect you to continue as contributor. So we're not don't go away. But thank you, John. And with that, we're going to do a rare thing and end early. Thank you all for contributing, and thank you for those in the room and remote, and we'll see you in Madrid.
Thank you.